This video is part 2 of the section 5.8 video for Math 95. In the first part, we covered solving equations by factoring, and now we're going to do some application problems or some word problems where we'll have to factor in order to solve them. Let's start by identifying our problem-solving strategy. The first thing to do is to identify your variable or variables. That is, figure out what in the world it is that you're looking for as your answer. A lot of times in these problems, drawing a picture will help you out. Next, you're going to write down an equation that has something to do with your variable. Then you'll solve your equation, and then you'll check your answers, both back in your original equation and also to make sure that they seem reasonable. First up is a problem from physics. This says after t seconds, the height of a model rocket launched from the ground is h of t equals negative 16t squared plus 80t. And then it asks us, how long does it take the rocket to reach a height of 96 feet? And when will the rocket hit the ground? Before we start trying to answer the questions, let's take a closer look at the information that we've been given. They've given us an equation where if you plug in a number for the t, it will tell you how high the rocket is after that amount of time. So the first question asks us, how long does it take the rocket to reach a height of 96 feet? Probably I'm going to want to take that 96 feet and plug it in for the height part of this equation and then solve for the t part, or the time. So for part A, I'm going to write 96 for the height equals negative 16t squared plus 80t. Now I have an equation that I'd like to solve. Just like earlier, I'm going to start by getting everything over to one side of my equation so that I have stuff equals 0, and then I'm going to try to factor. So what I'm going to do is add the 16t squared and minus the 80t to get them to the other side. So plus 16t squared minus 80t. That gives me the equation 16t squared minus 80t plus 96 equals 0. Now I want to factor the stuff on the left. I'm really hoping that I can pull something out of these terms so that the numbers will get a little smaller. And it turns out that you can factor out a 16, which leaves behind t squared minus 5t plus 6. And that whole thing still equals 0. Now, if you didn't notice that you could pull that 16 out, that's okay. You can still solve this problem by factoring. It's just that when you try the a times c method, you'll have 16 times 96, which is going to be really big. Having noticed that I could pull a 16 out, I made my problem a lot simpler. Now that I've pulled that 16 out, I can factor t squared minus 5t plus 6, which is a little easier. I believe this should factor into t minus 2 and t minus 3. I can do a quick check in my head to make sure that that adds up correctly. When I FOIL this, I'll get t squared minus 3t minus 2t, which adds up to minus 5, and negative 2 times negative 3, which add up to that 6 there. Now that I have this factored, I'll take each factor and set it equal to 0. But that 16 doesn't need to be set equal to 0 because it's not a variable. I've got 16 multiplied by something equals 0. I know that one of these three things needs to be 0, but there's no way that 16 will ever be 0, so I don't have to worry about that one. I can say t minus 2 equals 0, or t minus 3 equals 0. And that gives me two possible answers. T is 2, and t is 3. Now I'm going to check my answers for reasonableness. Does it make sense that I would get 2 times at which the rocket gets to a height of 96 feet? Could it happen both after 2 seconds and after 3 seconds? I think it is reasonable. When my model rocket gets launched, it goes up, and then it comes back down. So at some point, it hits 96 feet on the way up and also on the way back down. So on the way up, it hits 96 feet at 2 seconds, and on the way back down, it hits 96 feet at 3 seconds. And now that I've convinced myself that my answer makes sense, I can go ahead and write it down as a complete sentence. The rocket reaches a height of 96 feet at both 2 and 3 seconds. Now we still have a part B to answer for this question. It asks, when does the rocket hit the ground? And remember that our formula for height is the height equals negative 16 times the time squared plus 80 times the time. It almost doesn't feel like they've given us enough information here, but there's a little piece of information hidden. What's the height of the rocket when it hits the ground? When it actually hits the ground, it's 0 feet above the ground. So I can plug 0 in for the height part of my equation, making this 0 equals negative 16 t squared plus 80 t. That leaves me with an equation that I can solve. Notice that it's already set equal to 0, so all I need to do is factor the stuff on the right. I look at my two terms, and I see that they have a t in common, and I remember from earlier that they also have a 16 in common that can be pulled out. I'm going to factor out a negative 16t. I have a habit of always factoring out a negative when the first term is negative. So this ends up being 0 equals negative 16t multiplied by a regular t and a minus 5. Now I have two things being multiplied together and equal to 0, which means that one of my two things has to be equal to 0. Either negative 16t equals 0 or t minus 5 equals 0. Now, for negative 16t to equal 0, that would mean that the t would have to be 0. For t minus 5 to equal 0, that means that the t has to be equal to 5. Now we've got our two answers, let's check them for reasonableness. Does it make sense that the rocket would hit the ground after 0 seconds? It really doesn't, because the rocket hasn't gone anywhere yet. It does make sense that its height is 0 at 0 seconds before it even lifts off, but that's not when it hits the ground after its whole trip. However, it does make some sense for it to hit the ground after 5 seconds. Remember, it went up and then it went back down. So 5 seconds later, it hits 5 seconds seems like a reasonable amount of time for the rocket to take to be in the air. I'd be a little bit worried if I was writing something like the rocket hits the ground after 500 seconds. That seems like that'd be a long time. But 5 seconds seems reasonable, so I'll go ahead and write my answer down as a complete sentence. The rocket hits the ground after 5 seconds. Our next example comes from economics. A company finds that the cost of producing X widgets is given by this equation, C of X equals X squared minus 15X plus 50, and we'd like to know how many widgets they can produce for $9,500. So again, let's just take a closer look at the information we've been given. The X in this scenario represents the number of widgets that they're making, and the output is the cost of making that many widgets. I've been asked for how many widgets they can produce for a certain cost. So I think what I want to do is take that cost and plug it into the equation where the output would be, and then set it equal to x squared minus 15x plus 50. Now I've got an equation that I can solve for the number of widgets that they have to produce. The first thing that I need to do is get all the stuff on one side and a 0 on the other side. So I'm going to start by subtracting 9,500 from both sides. That gives me 0 equals x squared minus 15x minus 9,450. Now what I want to do is factor this thing. Now, I don't know what factors of 9,450 add up to negative 15, so off to the side, I'm going to go ahead and make a list of those factors. As you can see, there's an awful lot of possible factor pairs, but if we run through all of them, eventually we find that 90 and negative 105 multiply together to be negative 9,450, but add together to be negative 15. So this lets us continue on with our factoring, making this x minus 105 times x plus 90. And don't worry, we wouldn't give you a problem that takes quite this much time to factor on a test. However, now that we've got it factored, I can set each factor equal to 0, x minus 105 equals 0, or x plus 90 equals 0, and that gives me two possible answers, x equals 105 or x equals negative 90. Now's that time to check our answer for reasonableness. The question was, how many widgets can they produce for $9,500? So is it possible that they could make 105 widgets for $9,500? Sure. Is it possible that they could make negative 90 widgets for $105? That answer doesn't really make sense. You never make a negative number of some product. So we're going to stick with our answer being 105 widgets. Our next example is about the dimensions of a room. A rectangular kitchen has length 2 feet longer than its width. If the area of the kitchen is 120 square feet, what are the dimensions of the room? This is one of those problems where drawing a picture can be really helpful. So they tell me that the kitchen is rectangular. So I'll start by drawing a rectangle. The length is 2 feet longer than its width. I know that the area is 120 feet, so I'm just going to write that one down, 120 square feet. And I want to find out what the dimensions of the room are. So let's say that the width gets marked down as W. Then I know that the length, this side, is 2 feet longer than the width. So it's the width plus 2. Well, now this is sort of getting somewhere. I know that the area is 120 square feet. I also know that the way that you find area is length times width. So that means that the area has to be length, which was W plus 2, times width, which is W. And that has to equal 120. Now I have an equation that I can solve. Notice, though, that my equation isn't set equal to 0, and it's not in standard form yet. In other words, I haven't multiplied everything out on the left side. So let's go ahead and do that part. When I multiply this W through, I will end up with W squared plus 2W equals 120. Then I'm going to subtract the 120 from both sides so that I get the whole thing set equal to 0. W squared plus 2W minus 120 equals. That gives me an equation where it's all set equal to 0 and the left-hand side is something that I can try to factor. Now, I notice when I look at this for a little bit that things that multiply together to be negative 120 but add to be positive 2 can be positive 12 and negative 10. So this will give me two possible answers. I take each of my two factors, set them equal to 0. W plus 12 is 0, or W minus 10 is 0. And that gives me W equals negative 12, or W equals 10. Now I need to check my answer for reasonableness. Does it make sense that the width of the kitchen would be negative 12 feet? No, probably not. We don't usually measure distances in negative numbers. So the answer that makes sense here is probably this one. The width of the kitchen is 10. So the width is 10. What does that make the length? We knew that the length was supposed to be 2 feet longer than the width, so the length will be 12. And sure enough, if the width is 10 and the length is 12, then the area does end up being 120, since 112 times 10 is 120 square feet. So I'm confident now that my answer makes sense. I'll go ahead and write it down as a complete sentence. The width of the kitchen is 10 feet and the length of the kitchen is 12 feet. Okay, our last couple of examples involve the Pythagorean theorem. And yes, this is something you're going to need to know for the test. The Pythagorean theorem says if you have a right triangle, you can label the sides A, B, and C, where the hypotenuse, the long side, is always the C. Then it's true that A squared plus B squared equals C squared. This isn't too hard to remember, but the most important part is to remember that that C squared guy is always the hypotenuse, always the long side. So this example says, find the sides of a right triangle where one leg is 5 meters, the second leg is unknown, and the hypotenuse is 1 meter longer than the unknown leg. This sounds like a great time for a picture. I know that I'm dealing with a right triangle, so I start by drawing a right triangle. I don't know what it really looks like, but as long as I've got a triangle there, I can start labeling it. I know that one of the legs is 5 meters. The leg part means one of the two shorter sides. So I'll label one of the sides as 5 meters. The second leg is unknown, so the other short side is something I don't know. I'll go ahead and call it X. And then the hypotenuse is 1 meter longer than the unknown leg. So that means that the long side, the hypotenuse, is the short side plus 1. Now I have a triangle fully labeled, and I know that it's a right triangle. That means that I can plug those things into the Pythagorean theorem. The Pythagorean theorem here tells me that my short side squared plus the other short side squared equals the long side squared. Now that I have an equation, I'm going to start simplifying everything that I can and see what happens. So x squared I really can't do anything with, so I just write x squared. But 5 squared is 25. And on the right-hand side here, x plus 1 squared means x plus 1 multiplied by itself, and then I can FOIL. So I'll have x squared plus x plus 1, and then over here I've still got the x squared plus 25. Now I'm going to combine like terms if I can. I get x squared plus 25 equals x squared plus 2x. Now this looks like a polynomial type equation, so I'd like to get everything set equal to 0 so that I can try to factor and solve. So I think I'm going to go ahead and subtract x squared and 25 over to the other side. That gives me a 0 on this side, and this x squared and that x squared cancel out, so I get 2x minus 24. Now at this point you're welcome to continue factoring, but if you look closely I think you'll see that you actually know how to solve an equation like this pretty easily. If you have 0 equals 2x minus 24, you can add the 24 to both sides to get 24 equals 2x, and then divide both sides by 2 to get 12 equals x. So that tells me that the length of the unknown side is 12 meters. So one of my sides is 5 meters because they told me. The other short side is 12 meters, and the hypotenuse is 13, or one longer than the unknown side. And that all seems like a pretty reasonable thing. None of my answers are negative, and the hypotenuse came out as the longest side. So I'll go ahead and write my answer down. So the two legs were 5 and 12 meters long, and the hypotenuse came out to be 13 meters long. All right, last example. I'm installing speakers in my living room, which is 40 feet by 75 feet. I need to run speaker wire along both diagonals of the ceiling. How much wire do I need? Once again, I would say that this is a great opportunity to draw a picture. So the ceiling of the living room is a rectangle that is 40 feet by 75 feet. And I need to run wire along both diagonals. Do you see the right triangles in this picture? What I see is that the diagonal makes the hypotenuse of a triangle that has height, one leg is 40 and one leg is 75. Then I can use the Pythagorean theorem to figure out what this other side is. If I go ahead and call that diagonal D for diagonal, the Pythagorean theorem tells me that 75 squared plus 40 squared equals D squared. So now I'll go ahead and simplify my equation as much as I can and see if anything good happens. 75 squared is 5,625, and 40 squared is 1,600. Add those together, and we get 7,225 equals D squared. So I'm looking for something that multiplied by itself equals 7,220. Now that might not be something that pops out at you right away, but if you take the square root of both sides and solve this little equation with the square root method, you'll find that D is the square root of 7,225, which is actually just 85. Now I know that the diagonal of a square, or the hypotenuse of a triangle, is always the longest part. So it makes sense that this 85 number comes out as larger than the 75 or the 40. I think this is a reasonable answer for the diagonal. But we're not quite done yet. I needed to string wire along both diagonals, so I need not 85 feet, but 85 multiplied by 2, which is 170 feet of wire. So I need 170 feet of that. Brings us to the end of our applications for section 5.8. So go ahead and get started working on your homework.